This is a video about the empirical rule. The empirical rule is used when a distribution is approximately bell-shaped and symmetric. When this is the case, we can often use the standard deviation to help us describe the population using this empirical rule. Our rule states that approximately 68% of the data is within one standard deviation of the mean. Approximately 95% of the data is within two standard deviations of the mean. And 99.7% of the data is within three standard deviations of the mean. So what we're doing is we're counting how many standard deviations away we are from the mean, and that lets us give an approximation for the amount of data found in that region. One thing to note is sometimes we say almost all of the data rather than 99.7%. So let's practice drawing on this graph here. We see a histogram that is approximately symmetric and bell-shaped. So our mean is found right here in the middle. There's mu. And what we want to do is count standard deviations up and down. So if I move over to here, this is mu plus one standard deviation. If I'm thinking of this distance right here is sigma, okay? I can go up again, one more sigma, and this would be mu plus two sigma would be the value. And go up again, another sigma, I have mu plus three sigma. I can also go backwards. This distance is sigma, but the value would now be the mean minus a sigma. Go back one more. Standard deviation, this would be mu minus 2 sigma. And one more, this would be mu minus 3 sigma. Now, what does that empirical rule tell us? It says if we want to look from one standard deviation below the mean up to one standard deviation above the mean, so all of that area that is between mu minus sigma and mu plus sigma, all of this area right here, from here to here, is 68%. Okay? 68% of the data is found in between there. Okay? We can also look two standard deviations above and below the mean. So two standard deviations above and below the mean. So kind of this green area from mu minus 2 sigma to mu plus 2 sigma. This would be 95% of the data. 95% of the data. And then finally, we can think about for three standard deviations above and below the mean. And so here we can think, we'll switch back to pink, from here all the way over from mu minus 3 sigma to mu plus 3 sigma, this will be 99.7% of the data, or we can say almost all of the data. And so notice pretty much everything is found on that interval, from mu minus 3 sigma to mu plus 3 sigma. There's only just a little bit of data that is outside of that. For the 95%, from mu plus minus 2 sigma to mu plus 2 sigma, we see some data that is outside in that tail. And then for 68%, from mu minus sigma to mu plus sigma, we see 68% of the data is contained on that interval, but there's still a good bit left over outside. So let's talk about how to do some problems and answer some questions when this empirical rule is involved. So let's say that there's a license exam and we know that it is approximately symmetric and bell-shaped, which means the empirical rule is appropriate. And we know it has a mean score of 100 points with a standard deviation of 10 points. So I know that mu is 100 points and sigma is 10 points. And we're asked to use the empirical rule to approximate the percentage of test takers scoring between 90 and 110 points. So this is where I like to draw a graph to help me think about what's going on. So I'm going to draw a little histogram, a little bell-shaped curve. Not perfect, but close enough so we can think about what's happening. I'm going to put my mean in the middle. And instead of writing mu, I'm going to write 100 because that is my mean. I know what it is. It's 100. And now I want to think about counting by standard deviations above and below. So my standard deviation is 10 points. So one standard deviation above the mean would be at 110 because that's 100 plus 10. Two standard deviations would be 120. Three standard deviations would be 130. I can also go backwards. Now I need to subtract 10 each time. So 90 80, 70. Okay, think about it like that. Now, what is my question asking? It's saying what percent of the test takers scored between 90 and 110 points? So where are 90 and 110? I can see 90 is right here and 110 is right here. And so what I'm looking for is this area between them. What is that area approximately? Well, one thing I can notice, what did I do to get to 90 and 110? In each case, I moved by one standard deviation. So I went up one standard deviation and down one standard deviation. So another way you could think about this question is it's saying what percentage of test takers are within one standard deviation of the mean? Well, what percent is between one standard deviation? That's our 68%. Remember, our empirical rule says one standard deviation is the 68%. Within two standard deviations is the 95%. And within three standard deviations, you have almost everything. So here I'm within one standard deviation up and one standard deviation down. So that's about 68% of the test takers. Okay. All right, so let's look at another one. Okay, so now we have the same licensing exam. We still have a mean of 100 points, and we still have a standard deviation of 10. Now we know that 2,000 people took the exam when it was offered last fall. We want to know about how many scored between 80 and 120. So let's draw again our bell-shaped curve to help us think about this. So we put 100 in the middle. I know my standard deviation is 10, so I can count by tens. So 110, 120, 130, 90, 80, and 70. And where am I looking here? Let's see. For this question, it says 80 and 120. So I'm here at 80 and 120. And notice this is my mean minus 2 sigma, or 100 minus 2 times 10, right? That's how I got to 80. This is my mean plus 2 sigma, or 100 plus 2 times 10. So where I'm looking right now, this green that's being shaded in, all of this is the area within 2 standard deviations of the mean. So what that tells me is that this area is 95% of the data. So if this question had asked what percentage of the data or what percentage of the test takers scored between 80 and 120, it's 95% of the test takers. But we want to know how many, so we need to find 95% of 2,000. 95% of those 2,000 test takers, and 95% of 2,000 is 1,900. So 1,900 people, oops, switch to my eraser accidentally. 1,900 people scored between an 80 and a 100. 120, excuse me. All right. So those two problems had kind of nice numbers. It was easy to kind of count by tens and count by our standard deviation. Let's look at one that might have some slightly messier numbers. We've got some decimals involved now. Okay. All right, so a bottling plant is testing its machine that fills 16-ounce soda bottles. They find a sample to be approximately symmetric and bell-shaped, and it has a mean of 16.1 ounces and a standard deviation of 0.2 ounces. And so we want to use the empirical rule to approximate the percentage of bottles between 15.5 and 16.7 ounces. So I look in here, and it says that my mean is 16.1 ounces, and my standard deviation, sigma, is 0.2 ounces. So in the last situation where I counted by tens to figure out how many standard deviations away I was, now I need to count by 0.2 ounces. Okay, so a little bit harder to count by, but still doable. So let's draw our picture to help us. Our mean is 16.1. Okay, and so let's approach this a little bit different. Instead of counting out and writing all pieces, counting by that standard deviation, 0.2, 0.2, 0.2, let's put the 2 points that we're curious about. So 15.5 and 16.7. And let's see how far away each one of them is from the mean. So how far is 16.1 away from 16.7? Well, I would subtract them. So I could think this is 16.7 minus 16 point, oops, wrote that in the wrong order, 16.1. Okay, so that tells me that they are 0.6 away from each other. And 0.6 is how many standard deviations? Well, I want to see how many 0.2s are in 0.6, so I would divide 0.6 divided by 0.2, and that is 3. So what I have found is that distance is 3 standard deviations above the mean. Okay. Let's check the other one and see how far away it is. So I'll now do 15.5 minus 16.1, and I end up with 0.6 again. Okay, so this distance is 0.6, but how many standard deviations is 0.6? Well, it's that same as that we just did. We'll divide by the standard deviation. 0.6 divided by 0.2. How many standard deviations are in 0.6? We'll do that division, and we end up again with 3 sigma. So what I notice is 15.5 and 16.7, they are both 3 standard deviations away from the mean. So I'm sort of looking at this area. Okay, I'm looking at this green area here. Okay, and what does my rule tell me? My empirical rule says that 99.7% of the data, or almost all of the data, is found between within 3 standard deviations of the mean. So this area is almost all. And now it's not I didn't draw this to scale, so it does look like I have some tails hanging off, but I really just used the diagram to help me visualize how far away I am. And you get that distance and you divide by the standard deviation to figure out how many standard deviations you are away. So that area is almost all. So almost all of the sample is between 15.5 and 16.7 ounces. You may also say 99.7%, just kind of depending on how you're talking about it. All right, so let's look at one more. So we're still at that bottling plant. We still have a mean of 16.1 ounces. And we still have a standard deviation of 0.2 ounces. So now we have a sample that has 1,478 bottles, and we want to know how many contain between 15.9 and 16.3 ounces. So again, I'm going to draw a picture to help me. I'm going to draw this kind of symmetric bell-shaped curve. I'll put my mean in the middle of 16.1. And I am concerned with, let's see, 15.9 and 16.3. So if I want to think about the area I'm looking at, I'm trying to figure out what percentage falls in this area. And then I'll use that percentage to figure out how many there are. So let's see how many standard deviations away these are. So if I go above the mean, this distance, 16.3 minus 16.1, if I do that subtraction, I get 0.2. And so remember what we're doing is we're trying to figure out how many standard deviations away this is. Well, 0.2 is how many standard deviations away. 0.2 is how many 0.2s away. So that's a division problem. 0.2 divided by 0.2, that's 1. Oh, and that makes sense. We went up by 0.2. That's equivalent to 1 standard deviation. So 1 sigma up. Now, how far did I go down? And you may be able to notice I also went down by 0.2. But if we wanted to do this out with the calculations, maybe we didn't notice it. We would think 15.9 minus 16.1, and that equals technically negative 0.2. That negative is indicating a backwards direction. So how many standard deviations is that? Negative 0.2 divided by 0.2. Well, that's also 1 standard deviation, but it was below the mean, so we can think of it as a negative. But still, this distance is 1 sigma. So what's going on here? All of this data I'm looking at is within 1 standard deviation of the mean, and the empirical rule says that 68% of your data is within 1 standard deviation. So I know that 68% of the data is here. Okay. Well, now let's go back to my question. We actually want to know how many bottles, not just what percentage of them. So I will need to find 68% of 1,478. And if I do that, I end up with a decimal. I need to round a little bit, but we'll round it to 1,005 bottles. So approximately 1,005 of these bottles in the sample have between 15.9 and 16.3 ounces.